and find the actual project assignment. Oops. And that is assignment 2 right here. Yeah, this was it. Okay, so in this problem, and we read over it the other day, Tuesday, and the only difference in it and the first assignment 1 is that you need to add an input, and then what does this do to our logic, this addition? What do we have to do? We have to add what to our logic?
A decision?
Yes, we have to add a decision, okay? So those two things, so do we need to start over, or can we possibly use what's in assignment 1? Okay, so what I would do is I would open up the pseudocode for assignment 1. Who has one that they want us to use? Thinks it's pretty good.
Mine's good.
Okay, we'll go to Faith. All right, so let's go to Face. That way hers will already be graded, right?
Yeah.
Did you put it in here yet, or is it in chapter 3?
In chapter 3.
Okay. All right, so here we go. Come open. Must have popped to another window. Nope. Oh, not it. Oh, I see. You've got it down below. Okay.
Yeah.
All right. That's fine. That's good. That's good. Good idea. Okay. So in, I think I'm going to copy this and put it in Text Wrangler so I don't have all those squiggly lines like Word likes to do. Okay, so we have variable desk, variable tables equals 0. So those were already in number 1, right? Okay, so she added variable wood type for the decision. Then she added her constants. Mahogany equals 75, oak equals 100. Now, one thing that you probably want to go back and do, which you won't, is these are also constants, right? Because those values don't change either.
Right.
So you could go up here, even though you didn't use them in your first one, and say desk cost or whatever equals 65, and so that if you wanted to ever go and change that cost, you could just change it up here.
But don't you like take the input, like when you make it a constant, does that just eliminate the input? She has
No, she's asking for the number of desks, not the cost of desk.
You would have to name it something other than.
Oh, I see what you're saying. Yes, you would have to name it something. Is that what you were saying, Robert? No, here's what she would have to do is something like var desk cost equals 65. Okay, and about var table cost equals 155. Now, when I do that, what else do I have to change? Oh, I put semicolons in them. Right. I have to change in the equation here. I have to say times desk cost and times table, right? Plus mahogany. Okay, so there was 2 ways you could have done it. You could have left this statement out here. This is probably a more efficient way. When I was working with Dakota, just for the sake of not changing number 1, you could have left this in number 1 and then just had total equals total, oops, total, if I can spell, plus mahogany, okay? So we could have done it this way versus this statement. Either way is correct. I'm just saying if you really wanted to take just assignment 1 and not change it and just add your ifs, okay? Everybody follow? Okay, so for our for our pseudocode, in fact, let me go back and do that because, oops, I don't want to do that. I want to do edit, redo, edit, redo. What was that? Redo, paste, and edit. Okay, so if I'm going to do it like, see, the thing about that is that I don't have to put this calculation in twice, right? Because regardless of, did I do that right? Yeah, I need to do it down here. Oh, this statement is up here, so I wouldn't even have this else if, right? Because if it's pine, then I don't care. So let's see, and no else. So I would only have one else. Okay, so this one would be more, and so I only have one end if. Oh, there we go. So does that make sense, everybody? This is the way it was already in assignment 1. Now the way Faith did it is not incorrect. It's perfectly fine. But this keeps us from changing anything else. Plus, if it's pine, we've already calculated that up here. So it doesn't have to be another if statement or an else side of the if. Because we already know if it's mahogany, it's going to go here and drop out. If it's oak, it's going to go here and drop out. If it's pine, it's just going to drop down here and print out the total, right?
Yeah.
Everybody follow? Is that a little more straightforward logic? You'll see that?
My question was, if we were just, because I was thinking it from a furniture storage point of view, that if I'm selling coffee tables, I'm not just going to sell 30 and add $100 extra for the mahogany, and then just sell one and add $100 extra.
Oh, I see what you're saying. You're saying you would add 100 for each table. Well, but I didn't put that in the problem.
Okay, that's why I did it.
But that's good thinking, because it might indicate in the problem, because if they're saying they're all mahogany, I guess they're only adding the additional because they're buying, as you could look at it this way: if you buy a quantity, then you get a break. That's another way of looking at it. Okay, but yes, that's thinking too. Oh, look at this! I didn't get that in all cap. So this is actually pseudocode. Now you could actually have put num by all of these because this is pseudocode, but we're doing this because it matches the JavaScript, right? Okay, so anybody have any questions on the pseudocode? Is there anybody that was just stumped and didn't even start it?
I started it, but I kept having issues with my if and else.
With your if and else?
And then what it would do was it would display all 3 prices at once, and I couldn't figure out how to.
But did you submit that like it
Yeah.
was? Okay,
I
good,
even sent
great.
an email about it.
Does this make sense then?
Yeah.
So, kind of. Tell me what doesn't.
Well, until I see it run, and her setup is just different from mine.
Okay, how is yours? Okay, let's look at your pseudocode. Did you have pseudocode?
Yes.
Okay, let's go to your pseudocode. That's Ronald. RW. Is yours in chapter 3? Yes. Okay, so you've got input. Now, here's one thing that you want to remember with pseudocode.
I just changed it to variable.
Yeah, that's fine. But all these inputs you don't have, right? So you do input. Let's see, which one do you input? You do input lamps and tables and wood type. So I guess you could leave input there, but you do not input total. You don't input this. and it really makes more sense to put your input after your declarations. But I know there was somewhere, somebody coded it. I can't remember who codes it with the input on it. Because it will work that way, but it really makes more sense if we get all our declarations. Well, I was trying to get it lined up there. If we get all of our declarations, and do we need a pine variable? No, we really don't need a pine variable because we don't care if it's pine, but we do when we actually ask the user for the input. We do need to include pine in their options because if we don't, nobody knows they can enter pine, right? And then they would get a charge. It would have to fall on one of the other two. All right, so then you said total equals, and here again we would make these into constants like we did on faiths. And then if mahogany, then total, okay. And see, here's what the part, you did the same thing like how she was doing it, except for you did it twice because you left this statement in here like we do in assignment 1, but then you also did it again here, you see. So what we would do is we would just say total equals total plus mahogany. You called it mahogany, so you don't actually put 75. That's what the purpose of F mahogany. Yeah, you're saying, okay, you didn't ever put a wood, so this would actually need to say if wood equals mahogany, right? Equals mahogany. Then total equals, get out of here. See, that's why I don't like this silly word. Let's see. Go back over to text wrangler. I'll copy a new one. File, new, Command V. Okay, so this one now, so total equals, if wood is equal to mahogany, then total equals total plus mahogany, and you end if. Okay, and I was talking to Dakota about doing this way. This will work where you have just two ifs, but can anybody tell me why it's better to use an if else?
Because then it actually goes to, and then it actually makes the decision based on the input.
Right. It'll say it can drop out after the first one, right?
Right.
Okay, so it would be better. Do you see, Ronald, what we're saying? So this, what you did, and like this one, we don't need it all because nothing happens if it's pine, right? Okay, so if you get this pseudocode now, we're going to go back to, oh, where is, I guess it didn't leave yours open. Open recent. Come on, does that mean it didn't leave? Oh, there it is. Okay, so we're going to go back to this one that we fixed up of faiths, and we're going to code it in JavaScript. Okay, everybody with me on that? Anybody need any more pseudocode as to look at any other pseudocodes? Any questions?
I did my flowchart. I did a flowchart, but I did
You
it
did-
a little differently. I
Okay.
actually added another variable for the wood cost, and I used the constants to plug it in, and then
Okay,
did the final calculation at the very end using adding wood cost on the end.
okay,
That's how I did it too.
that's how you did it, Corey? Okay, let's look at, is your pseudocode or flowchart? Okay, let's see. I think I can pull those up easier than I can the flowcharts.
My flowchart's a PDF, so I don't know.
Yeah, I can probably put AG. Let's see. See if this is. Okay. Okay. In her flowchart. Okay, let's see how you did different. Variable wood cost, but you didn't set it.
That's because it does change.
Oh,
depending
I
on
see
the
what.
wood.
Okay, I got you. Okay, so input DLCT and wood type. Okay, if wood type is the same as mahogany or wood type is the same as oak, so if either one of those are true, then it's going to fall over here. So if, and then it's going to ask this if wood type is mahogany, then wood cost equals mahogany. Over here it's wood cost equals oak. And see, now over here you had to do this actual initialize that you wouldn't have to the other way. Total cost equals plus wood cost. But that's a good way too. That will work. We are having to make a few more decisions here, and we're having to use an extra variable in memory. But the thing that is good about this is that if any of this changed up here, then if you wanted to add more wood types or something, you could do that, but you're kind of using a constant and a variable for the same thing, right?
Yeah.
So it's not necessary, but if that logic makes more sense to you, there's not a problem.
It makes sense to me when I was
Okay.
doing it.
All right. Is that how you did it, Corey? Similar? Here, let's look at your pseudocode. So more different ways we look at solving, then it gives you ideas how different people. Yours is CC, right? No, that's Chelsea's. Corey, CT? Okay. Okay, variable lamp num, table num, variable lamp cost, table cost, variable wood type. And is that like the cost, the one like she was saying would cost, I guess?
Yeah, that gets tacked on to the
Mahogany, oak, and yeah, and you don't need the pine here. Okay, input lamp num, input table num,
end.
input.
You need the pine later on. So the WDTP turns into.
Oh, because you did this at the bottom. Yeah. See, you would not even need this wood if you do it the other way.
Yeah.
So, but that does work. You got an answer. So yours is similar. You did 3 ifs like Ronald did. Ronald did 3 separate ifs, right? Okay, so all of those ways y'all are thinking. That's what I want. You're putting something down. You're getting an answer. But what we do when we come to class is we learn a more efficient way to do it, okay? So that's what I want you to get through your head. There's no wrong way if your answer comes out right, okay? It's just that we want to think a little more structured, a little more less decisions if we can do it that way, okay? But I like it. You're thinking. That's great. Not everybody thinks alike. Thank goodness. It would be a very boring world, right? Okay, cancel that one. Okay, so we've got in Text Wrangler, we've got this pseudocode. And so now I'm going to do another new file for the JavaScript. Actually, I'm going to take this because she has her vars in there. We're just going to put it in JavaScript. Oh, why did that close out? I could do it here in Text Wrangler. This is a straight editor too, so open one that has I find one that has some HTML in it that I can get rid of. Okay, so I'm going to take this out. Put the pseudocode in there. Now we're going to work from here. Okay, first of all, we need to go in. So all I did was copy the pseudocode, right? So I want you to be able to see for every line of pseudocode what we're having to change for JavaScript, okay? Now I could go backwards, those of you that like to do the JavaScript first, but we're going to do it this way and see how much different it is. So first thing we need to do to our declarations. Now, if you had in your pseudocode put num, you would have to change that, right? Okay, other than that, our declarations are okay, and it will run without semicolons at the end. You're just safer to do that because that's kind of syntax, and it doesn't like would type being like that, so we're going to take that off. Although sometimes you can get that to work. I can tell you how that would work. I know what I did. Now it will. Whenever you copy and paste quotation marks from somewhere into JavaScript,
Because what kept turning them
yeah.
weird.
Yeah, it turns them. And so
after my equal sign, and I'm like,
yeah, and
why?
it won't accept it. So you always, if you copy and paste, have to change the quotations. You have to retype them. Okay. All right. So mahogany 75 100 total is 0. Desk cost and this one. Now our input. What do we change input to?
Prompt.
So we want to take the input off of the front and say desk equals prompt. Please enter the number of desk lamps to buy. Comma, oh, actually the comma goes, comma 0. Okay, so we've taken the first line of code after the declarations, which is our input, and I can put a comment here so that I see that that's what I'm doing. Change input to prompts, right? Okay, so this one would be the same thing, and since I'm lazy with typing, I'm going to copy and paste it, okay? Oh, I thought I let, yeah, there it is. Copy, only I'll have to change a few things. Paste, so this one is tables. Please enter the number of coffee tables. Okay, coffee tables to buy. Okay, this one, I'm copy it too, although it's going to be a little different. So this one is going to say wood type, which is wood type. Oops. Spell it right. Wood type equals, please enter the type of wood for the tables. Select mahogany, comma, oak, or pine. Okay. So everybody understand that? Yes.
After the wood type, should there be a 0 after it, or shouldn't there be a 0? Because it's a string.
Oh, it is a string. So I could say, I'm just going to say wood type here. Type wood. So now that's what should print out in my dialog box, right? Let's type wood instead of a 0 being there. Because if a 0 was there, that would indicate to the user that they could put numeric in that field, and we don't want numeric
I
there.
actually did it a little different. Where you put type wood, that's where I put mahogany over pine.
Okay.
Yeah, that's what I did too.
Oh, that's a good idea. Okay, so right here, she put mahogany, if I can spell it. I have to think about it every time. Mahogany, oak, or pine. So now that will actually come up instead of having it in my quotes here. Okay.
Yeah, I listed wood type as an if-then statement. So if tables is greater than 0, then it will ask what wood type. So if they're not getting any tables, then it would be a need to specify wood type.
Oh, you're saying they may not get tables. Okay. That's a good idea. He thought for an exception. Did you hear what James said? He thought of an exception. What if the user only wanted desk lamps and no coffee tables? then they don't need to ask for the wood type. Very good. Okay. So total equals desk times desk cost plus tables. Oops, I don't need that other parentheses in there. Tables times table cost. So we're going to assume in our problem that they are getting both. And so we've got a total here. So now that statement actually does not change from pseudocode to JavaScript, right?
Mhm.
It's identical. Okay? All right, so now if wood type equals mahogany, so I am going to have to fix that, right? If wood type equals mahogany, and I don't have the word then in JavaScript. There are some languages where you use the word then, though. Okay, so instead of then, what do I have?
A brace.
A brace. Okay, and I can either put it there, or where I prefer to put it is here. So it can go at the end. Yes.
Should that be 2 equal signs?
Yes, ma'am. Thank you. Because we're JavaScript.
I know, that's where I had problems.
Yeah. So, and also remember, my quotes are not looking right either. Oops. Yes, remember in JavaScript, you only have to put 1 equal sign in pseudocode, but to measure, to compare, for a comparison to work in JavaScript, you have to have a double equals. Everybody understand why we did that? We changed it to a double
I
equals.
kept having problems with that.
Yeah.
Yes, I had.
Everybody does them. And even when you become a programmer, you'll still forget that sometimes. Okay, so total equals total plus mahogany. Do I have to change any of that? Except for my, no, I just put it like that. Else if, so else if, oh, I do need one more thing. What do I need before the else? Close the brace. Very good. I have to close the brace. Now if, oops, wood type is, what do I need? 2 equals, and then I got to fix these quotes here. Dreamweaver kind of cheats, helps me cheat. Okay. And then what goes in place of the then?
Open brace.
Open brace. Okay, so I open the brace. Total equals total plus O, semicolon, down. Closing brace is my end if, right? So I take this end if off. And I put a closing brace, and I think I got a space line, a blank line in between. Okay. And then this end if is replaced with what? Another closing brace, because the top, the very top if, oops, do I have one extra somewhere? Oh, wait a minute. I have an extra. No, it does not go there, because it's here. Why is that? That doesn't make sense. Hold on. That is it. Oh, this if closes here, else this if closes here. Okay, so we don't. This is actually the close, open, and closing for that if. Then output. What takes the place of output in?
Document dot write line.
All right, document dot write line and total. Now I could, did it tell you to output anything else or just the total? I think just the total, right? Some people did, but that's all right. Okay, so let's see how our coding is, how my coding is. Let's see if it works. This isn't spelled right. Okay. All right, so if I go up here and I say file, save as, because I don't want to save it as that one, this is going to go in my Google. And this is A2. Okay, save it. All right, so let me see if it works. Safari. Please enter the number of desk lamps. Let's say 2, because isn't that one of the results I gave you was 2 and 3? Mahogany, oak, or pine. Let's say the first one is mahogany. First time I ran it. Is that what I gave you to run it with?
Mhm.
Okay. 670.
Mhm.
So we did it right. Right? So if we want to run it again with the next values, what's the next values that I gave you in the test run? Three desk lamps.
2 desk lamps, 3 tables, and
Oh.
different
Oh,
wood.
the same other part. What kind of wood? Oak. Okay.
Will it still work if you capitalize the P in pine on this one, but they don't capitalize it?
In the comparison, okay, let's try that. Because it won't, if it's comparing, you can change, like, okay.
You can just do 2 uppercase, the two fixed for
Yes,
uppercase. and
yes, you
that
can
would
do
fix the
that.
problem,
2 upper,
right?
right. Oops, where was that? Oh, that's not what I want. Where'd I go? Okay, so what she was asking, what Chelsea was asking is, this is lowercase. If the user types in a capital M, will it still work for mahogany? Let's see. Okay, so I'm going to put 2. Okay, 3. Okay. And this time M-A-H-O-G-A-N-Y. Nope. So see, that's something that we might want to note for them, right? Now, the reason that is so important is because it's between the quotes and it's a comparison. So it's saying right here, or I could say, this is where it would be good to have an or statement. If I really wanted to catch all the exceptions, I could say, if wood type is the same as lowercase mahogany or wood type is equal to M-A-H-O-G-A-N-Y. Now, if they used all caps, I still wouldn't get it, right?
Mhm. Because
Okay, that's a couple of
all caps
exceptions.
mahogany is named constant.
Yes, it's the name constant, but what would make it different?
It's in between the quotes.
It's in between the quotes, so it's a literal, and the named constant is not a string literal. Okay, everybody follow what we're doing. Anybody need me to go over any of it? We okay with this one? So this is exactly what you need to do on the test. Code your pseudocode, copy it into your text pad, and then just make the changes line by line. There should be a line of pseudocode for every line of JavaScript. Okay? So that was what we did. And also, that was where I was telling you Dr. Singal's book. He has those PDFs in the content area in D2L that shows you line for line of code, how to do it from pseudocode to JavaScript. Okay? Anybody have any questions? We got it. Now, look, one thing that I want you to remember that on the test will be a big deal is that I want you to be sure that you have either a docx or a PDF and your HTML file, those two compressed to one file, right? And that's what you put in your test folder. And what will the name supposed to be? Can't just say like A2. It needs to say A2 underscore your initials or your name. Very good. Okay, please do that so I don't write over somebody else's, okay, when I download it. All right, so that's what I want you to be sure you do. That gives you 5 points for all that, all right? Okay, so we're done with that part. Everybody's ready for loops, right? You're gonna really confuse you now, okay? Who's done loops before? Anybody wrote loops? Matt has? Anybody else worked with loops? Well, loops are our third structure. So we're about to have everything, all the tools that we need to write any program that we want to write the whole rest of the semester. All right? So when we learn loops, we can do it all. All right? There won't be any program that you can't code. Now, we're going to learn about arrays, but arrays are really a combination of decisions and loops. Anybody have arrays in math? You remember? Yeah, you had arrays in math, in algebra, whatever. I don't know how, I can't remember what grade level they actually introduced them, or if it's not until college. I can't recall. It's been too many years. All right, so what we're going to do is start the PowerPoint then for chapter 3. That's not what I want. Google. There they are. Okay, here we go. Yes.
Shouldn't it be chapter 4?
Oh, I'm sorry. I forget that the first chapter was just kind of housekeeping type stuff. This is the third structure, so I got messed up there. Thank you. Let's see. Back. Yeah, you don't want to do 3 again, right?
Just got done with it.
Yeah, really. Okay. Looping. Really is fun to do loops, but it can be challenging. The thing about loops is that there's not just one way to code loops in JavaScript or in other languages, because you can use do whiles, you can use what's the others? While until. There's until loops. There's for loops. We're going to do for loops in here and while loops. Okay. And when you get to specific languages, you learn different ways to whether you test the loop at the beginning of the loop or at the end of the loop. So these are things that we'll learn as you learn other languages. All right, so the objective in this chapter is to learn the loop structure, using a loop control variable, nested loops, avoiding common loop mistakes, using a for loop, and common loop applications. Okay, so understanding the loop structure. We saw this at the very beginning of our book in chapter 1. We saw there were 3 structures, and this was the third. And this is the way it would look in a flow chart for Amelia. She does. Anybody else do flow charts in here? Okay. So, looping makes computer programming efficient and useful. One set of instructions can operate on multiple data sets. So instead of having to code it, if you wanted it to happen 3 times, you actually only have to write the code 1 time and determine how many times you're going to go through that execution of that loop. Get my book open here. Make sure that I don't miss something. Okay, so when we talk about loops, there's on page 118, there's the following definitions that we need to remember. Loop body are the statements within a loop. We don't really call in an if statement. We don't have a body. You could actually say you have an if body, because right after the if, there can be a number of statements that you execute if the if is true, right? Well, that's what this is. Only this is saying you could have if statements or if then else is inside your loop. And that will be part of the loop body. So we're going to have the loop structure is one of 3 basic structures in structured programming. It starts with a test of a Boolean expression. So what does Boolean mean?
True or false?
True or false. So we're going to test. There's always going to be a comparison to say, hey, am I done, or do I want to go through it again? That's all it's going to be. Yes or no, true or false. Okay? We're going to have a variable that tests that. Then you execute as long as the Boolean expression is true. So you're going to keep repeating the loop body as long as the Boolean expression is true. So it's referred to as a repetition, iteration, Or in our book, we're going to call it a while loop. We're going to say, do this while this Boolean expression is true. Okay? So let's see if we have an example here. At the bottom, I don't think this example, yeah, this example's in here. Let me see. Okay, so example of a while loop. While the quantity in inventory remains low, continue to order items. So it won't hit this end while until this is no longer true. So as long as this is not true, this is not true, then we're going to, or I'm sorry, this is true, then we're going to keep ordering items, right? Pretty simple. Make sense? This is just a logical decision here. While quantity in inventory remains low. So if it's no longer low, that's not very many details. You would say, well, how do I know when it's low? Well, this is just giving you a simple little generality of how a loop works, okay? We're going to get specifics before you have to write.
Name constants again.
Yeah, we'll have some named constants. Okay, end while signals where the loop structure ends. The structured loop has one entry point and one exit point. The body of the loop can contain any number of statements. It can include sequences, selections, and other loops. So you can have nested loops, just like you could have nested if statements inside other if statements. You can have loops inside loops, okay? So we have to really watch what we're doing. There's a loop control variable. The value is tested to control the loop's execution. Now, there are a lot of different kinds of loop control variables, and we're going to talk about some of them. Now, on page 119, there was a video that hopefully you looked at of the authors called A Quick Introduction to Loops, because those videos are there for you. Using a loop control variable, what you do, there are three actions that occur. With that variable, you have to initialize the loop control variable before you enter the loop. What do I mean by initialize? I know? What would I mean by initialize? Declare it. You have to give it a value, right? Mm-hmm. So we have to give it a value to start with. We have to either say the count is equal to 0 or count is equal to 1. We have to know where we're going to start. Then we have to, after that, we have to test the loop variable. If it's true, enter the loop body. So that's our Boolean expression. This is our Boolean expression. Okay? Alter the loop control variable value in the loop body. So there's always going to be at least two statements because we're going to do something in the loop body, and just before we leave the loop body, we have to increase our control variable, or we would be in the loop forever, right? We just keep doing it forever and ever, unless we increase it. Now this is called, normally this is a counter-controlled loop that we're looking at here. Okay, you need to control the number of repetitions, or else it's called an infinite loop that has no end. There's ways to control repetitions. You can use a counter to create a definite counter-controlled loop. What it means by definite is that it will always execute a specific number of times. So if you want that loop, say you're going to print out a number 10 times, and you start with, or you're going to print out the counter, you say set count to 0, and you want it to print out up to 10, then you would have the loop set to what? What do you set the loop to? 10. Because you're going to go 1, you started at 0. If you want to count to 10, not 9, then you would have to count it to set it to 10. Okay, so a sentinel value will create an indefinite loop. What that means is that you can say to execute the loop while the control variable is not equal to low, like in that first one. And so it would stay that way until at the bottom of the loop, somewhere you changed it to something else. So it's not a predetermined number of times that you're going to execute the loop. It's determined by the value of that variable. Okay? We're going to see some examples. It'll make a little more sense. Definite loop with a counter. It executes a predetermined number of times. It's also called a counter loop or counted loop or counter controlled loop. The counter is the numeric variable to count the event occurrence. The variable usually is initialized to 0. Doesn't have to be. It can be initialized to 1 or anything else. Example figure 4-2 is showing the counter controlled loop. So hopefully you have this in your book because my PowerPoint is pretty fuzzy there. It's on page 120. So on page 120, it's using a definite loop with a counter. And so what it says, first of all, the control variable is initialized to 0. So I still have my class, my main, all that. Here's my declarations. The only declaration that I need is a count. Okay? This is just a variable because this is a real simple program that's going to print out hello at 4 times. Or no, it says less than 4. So how many times is it going to print it out?
4 times.
4 times? It'll print it out when it's, yes, 4 times because it's going to print it out when it's 0, right? Okay, so I'm going to set count equal to 0, you notice, before the loop. So these two statements are before the loop starts. And the very first statement of a loop is what? What is the diamond mean? If, a decision. So remember what I was telling you is that's why we had to learn about decisions first, because you can't do a loop without a decision. Okay? Now, in this case, it's not really an if, it's a while. But it'll say while count is less than 4, and then we have a yes branch and a no branch. And on an if statement, we usually have the no out here, but on a loop, a lot of times they'll go straight down the bottom of the diamond because they're not wanting to loop anymore. Okay, so it's not really 2 branches, it's really a loop or no loop. Drop out of the loop. Okay, so while count is less than 4, yes, it is less than 4 the first time through, it's 0. Output hello. So in this program, while count the first time through, count is equal to 4. So the first time I execute it, it's going to go, count is less than 4, yes. Then output hello. So it's going to say hello. It's going to output hello. And then you notice in the loop body, this is the loop body, there's another statement. Count equals count plus 1. So now, oops, I said count 4. That's supposed to start out at 0. Amelia, you didn't catch me.
Sorry.
Okay. Just teasing. Okay, so count equals 0, so now it's 1. Count equals 1, because we added 1 to it, right? Okay, so now it comes back up. The flow chart shows us. Some of you may switch to flow charting during loops. I don't know. We have the pseudocode down here too. It's just not as easy to see sometimes. Okay, so then we say count is less than 4. Is it still less than 4? Yes. So now I print out hello again. Then I add 1 to count. So now count is 2. So now, is it still less than 4? Yes. So hello. Add another 1. It's 3. Hello. And now count is 4. So is count less than 4?
Yes. No.
No. Okay. No. That was a trick question. Okay. So displays and adds 1 to count. Next time count is evaluated, its value, so it goes down, it tells you 4 times until this is false, and then the loop ends, and so it's going to output goodbye, right? And then end. Okay? So on the pseudocode, you'll notice this is why it becomes more important to indent. It's not mandatory, but there's where you see the loop body is indented, right? So if I took this statement out, what would happen? If I take this box out, what's going to happen?
It's just stops.
Won't ever come out. It's called an infinite loop, okay? You'll probably have a few of those in your programming career. I have. Okay.
Yeah, there's some things you want to keep going on and on.
Yeah. Okay, so methods of changing the loop control variable. These are two ways you can change it. You can increment, which adds to the variable, which is what we did in that previous problem. Incrementing means adding. That's all it means. Or you can decrement. You can reduce the variable and test whether the value remains greater than a benchmark value. Sometimes you'll see them do that. So here's using an indefinite loop with a sentinel value. So we were doing what kind of a loop previously? There's two kinds of loops. The one we're getting.
Definite loop.
Well, no, yes, it is definite. What is another term? Counter controlled, right? It is a definite loop, but it with a counter control value. Okay, using an indefinite loop with a sentinel value. The loop execution time is based on the user input. The loop may be performed a different number of times each time the program runs. So we have something that's called the priming input instead of initializing the variable. Because with the counter, you've got a variable that you initialize. You just set that value, right? Priming input is where we ask the user, what input do you want to end this loop? What do you want the value of the variable to be for the loop to end? So that's why it's called priming, because there's nothing in it until the user tells you. So that variable is not initialized. It has to be declared. Right? Know the difference between initializing and declared? If I just declare it, what do I do? I'm just saying it exists, right? It's a variable that exists. Initializing means when I say equal to something. So if I say var count equals 0, then I've initialized it and declared it, right? Okay. So priming input is the first input that sets the loop control variable's first value. Then the sentinel value is the value that signals a stop to a loop. So here's the next one, which is on the page 122. This one says, here's my declaration. It's a string, should continue. So in JavaScript, it would still be var equals and in quotes, should continue, right? Mm-hmm. Right? Output, do you want to continue, yes or no? Okay, so that is what they're going to ask the user. This is actually the variable, so I'm wrong, that would not be in quotes. It's a string, but it's a variable, so it would say var should continue equals, and then I can initialize it if I want, or give it a value. So here I say, do you want to continue, yes or no? Input should continue. And so here is where they actually initialize or do their priming input, is they ask, they prompt. Here is the statement that goes out to the screen. Okay, so it's kind of confusing because they're echoing. This is what they're saying in their prompt. It would say, should continue equals prompt. Do you want to continue, yes or no? Y or N. That's what we could put in our little box, is Y or N, like we did mahogany, oak, and pine for them to enter it. We would put Y or N, okay? And it is going to make a difference if it's capital or lowercase, because we're going to do a comparison of the string right here. So you either need to do ors, or when you put up here, do you want to continue, or when you put it, you can put in your print to the screen that the lower or uppercase only, or something like that. Okay, to warn them that they have to put uppercase or it won't find it. Okay? Or you could do Lord. All right, so they have told us what this is. So then if should continue is equal to y, then yes it is, then output hello, output, then you have to ask again. So instead of just a count equals count plus 1, that would work on a counter control loop, but because this is a sentinel value, I have to ask again at the bottom. Do you still want to continue? Okay, so if I come up here and I test and it's still yes, then I do hello again. If it's no or in, then I do goodbye. So let's try that one and see how it works different. So my control variable in this case is what? What? Okay, that's what the value of it's going to be, but what is the name of my variable? Should continue, right? So this is should continue is equal to, okay, I don't have a value yet, right? There's no value to it until I get to here, and I ask them to input y or in. Well, we're hoping the first time through it's a y, right? If not, it's just going to say goodbye. Right? If they did put in first, it would just drop right down and say goodbye. No hellos. Okay? So let's say the first time through, they primed it with a y. They put a y in there. So we come down. Should continue, is it the same as y? Say yes, so we would say hello. And then we say, okay, do you want to continue? Yes or no? Okay, so if we have them put yes in again, they put yes again, then we're going to say hello again. So now the next time should continue, let's just say, no, I've seen hello enough. So then I go down, no, so I output goodbye. So you see the difference between a definite counter-controlled loop and an indefinite sentinel value.
All right, I'm a little confused,
Okay?
because it looks redundant, because at the bottom of your loop, it says input should continue,
Uh-huh.
and it goes back up to should continue.
Uh-huh. No, it doesn't go back up there.
Well,
See, it goes here, below it. See, input should continue, while should continue equals y. Go down here, input should continue. And then it's only going to go to here. It's not going to go back up to there. That's real important. That's good you saw that. See, that's what I was pointing out here. That's why some people may rather use the flow chart now, because you can't tell in the pseudocode when you say input should continue, you never go back up there because the while loop starts here. You don't go back up above the while loop when you get to the end of it. Okay? You see that? No? Everybody get it? Okay, so this one is just a real straightforward. We're not actually doing anything but printing one thing out, right? Okay, the next thing, this is probably, I wanted to at least get to nested loops today, and then we're going to stop where it's for loop. I may just do this one. Okay, using nested loops. So a loop inside of another loop. Outer loop is the loop that contains the other loop or inner loop. Then these are used when two or more variable values repeat to produce every combination of values. Okay? All right.
If I start doing my flow charts in color to help me.
In
keep
color,
track.
yeah. So you can tell. Okay, so here's an example. Creating a quiz answer sheet. This is on, where's this at? This is on page 125. Okay, and it's showing you an example quiz answer sheet. This is what we want to print out as a result of this program. Okay? That's what we want to print out. We want to print out quiz part 1 and then 1, 2, 3. Then when it hits 3, I want to start part 2. So this loop has got to be going on inside this loop that prints the parts. Okay? See that? So this one is going to be a definite or indefinite?
Definite.
Definite. Both loops, right? Are both loops counter controlled? Yeah, there's question counter and part counter, right? So because we know our parts are only going to go to 5 and our question counters are 3, maximum of 3, right? Okay, so when we start it, it says our declarations, we have a part counter, a question counter, then we have constants because we know when parts is 5 and questions are 3, so instead of using 5 and 3, we're using constants. Okay? We also used a constant for the label. Part label is part, line is a line inside there. Okay, so because that's duplicated and you don't want to have to put it every time. If you put it in a variable, then you don't have to worry about it. So then it says output quiz, which was what was supposed to go here at the top, right? So output quiz, then part counter, set it equal to 1, because that's what this first one is. And so it says, as long as part counter is less than or equal to parts, because I initialize parts to 5, right? The constant 5. So as long as it's less than or equal to, because if I just said less than, it would not print out this one. It would stop after it got to 4. Okay? So I had to say less than or equal to 5, or part counter is less than or equal to parts. And if it is, which the first time through, it's 1 right here, right? So I go here, output part label, part counter. So part counter in the beginning is a 1, so it's going to print out part 1, the first part of the loop. Then I need to start another loop that says while question counter is less than or equal to questions. So there it is, 3, but I had to initialize it to 1. So I say, yes, it's less than or equal to questions, output question counter and line. So the first time through, this is probably the last one we get to do. This one is, okay, I've got part counter that changes, and I've got question counter that changes, right? Okay, so the first time through, this one's equal to 1, part counter, and it's testing, and it goes over here and it prints out quiz, and then it prints out the label part 1. And then I'm in my nested loop right here, and it says output question counter and then the line. So it would print out 1 and the line, right? When I'm right here. Then question counter is equal to question counter plus 1. Oops, it was already 1. So I mark it out. It's now 2. I haven't done anything to part counter yet because I'm still in this inside loop, right? Mm-hmm. So I come down, go back up to the top. Is question counter still less than or equal to questions? Mm-hmm. Yes. So now I'm going to go through and print a 2 and a line. And then the last thing I do is that I add to question counter again. So it's 3 now. So I go down, back up. Is question counter less than or equal to questions? Yes. Yes, still 3. So I go 3 dot, go there. Now, I come down, I add 1 to question counter, so it's now 4. Go down, around, up, test. Is question counter less than or equal to questions? No. No. So now I drop down and I increment part counter. So I take part counter plus 1. So it's now 2. Come down this outer loop, up, over, test. Is part counter less than or equal to parts? Yes. Yes. So now I'm going to do part 2. Okay, so then I come over here, and that's where I output it. question counter equal to 1. So I'm going to go back, set my question counter to 1 again. And so then I say, is question counter less than or equal to questions? Yes. So I'm going to output question 1. And then I'm going to do that 3 times, right? So everybody see how it goes through?
Yep.
Okay, so it's going to keep executing until it gets to 5. And when it drops out here and makes this 6, it's going to come up all the way around. Is part counter less than parts when it's 6? No. Is it less than or equal? When it's 6, it is now. Yes, correct. But when I get this up to 6, it's going to drop out and end because it will have printed the quiz. Okay? All right, so we got our first part of loops and nested loops. And we have our test on Tuesday. So everybody be here. Okay? Hands-on test on Tuesday.